Question 1. In how many ways can a jury of 6 men and 6 women be chosen from a group of 10 men and 15 women? So there are 2 parts to this question, the number of men and, of course, the number of women. So I'll write M and W. In terms of the number of men, we are starting with 10 men, and we want to choose 6 of the 10. For the women, we are starting with 15 women, and we also want to choose 15 of the women. And since this is happening in the same situation, we're going to multiply the 2 cases. And if you evaluate that, you get 1,051,050. Question number 2. How many different sampler dishes of 3 different flavors could you get at an ice cream shop with 31 different flavors? So we know this is a combinations and not a permutations question because getting 3 different flavors, the order doesn't actually matter. So if I have my, bowl here, it doesn't matter where the ice cream ends up in the bowl as long as we're looking at 3 different flavors of ice cream. So since we have 31 to begin with and we're choosing 3 of them, the solution is simply 31 choose 3, which is 4,495. When playing poker, a flush is a hand with 5 cards from the same suit. How many different flush hands are possible? Since we know that there are 4 different suits, hearts, spades, diamonds, and clubs, there are 4 possible situations here. We get a flush from each one of them, basically. So each card, or each suit, represents 13 cards in the deck, because there are a total of 52 cards, and there are an even number of all of the suits. So in case number 1, where we have hearts, we have 13 hearts, and I want to choose 5 of them. So how many different ways from the 13 can I have 5? That is the exact same for all of them. So 13 choose 5 all across. And now, because these are all really separate situations, like I can't have a flush of hearts while also having a flush of diamonds, they're all separate, we are going to add our separate cases. Multiplying is if it happens within the same situation, but since these are separate, we add them. And once you evaluate, you're going to find that it's 5,148. So that means when you're playing poker, there are 5,148 possible flushes. Question number 4. There are 15 technicians and 11 chemists working in a research lab. In how many ways could they form a 5-member committee if the committee A must be chosen in any way? If the committee can be chosen in any way, we know that since there's a total of 26, because 15 plus 11 is 26, and I'm choosing 5 people to be a part of the 5-member committee, part A is simply 26, choose 5, which is 65,780. Part B must have exactly 1 technician. So if we're doing exactly 1 technician, we need to separate our technicians and our chemists. So of the technicians, so of the 15, we want to choose 1 of them. And then of the 11 chemists, there's only 4 possible spots left of the 5-member committee, so it's 11 choose 4. And then since this is happening within the same committee, they're going to be multiplied. And we're going to get 4,950. Part C is very similar. You know what? I just realized there needs to be an edit. There needs to be a part C with 1 chemist. Then really what I have is C is D, and then D is E. Okay, so part C, so 1 chemist, that means of the 15 technicians, we're choosing 4 of them, and then of the 11 chemists, we're choosing 1 of them, which is 15,015. Part D, having exactly 2 chemists, so following the same pattern, if we have 2 chemists, so that's 11 choose 2, that means there are 3 people left, or 3 positions left, that can be chosen from the 15 technicians. And that's 25,025. Part E, all technicians or all chemists. So this is 2 different situations because you're never going to have all technicians and all chemists at the same time. So if I have all technicians, that's simply 15 choose Oh, not 4, 5. If I have all chemists, that's 11. Choose 5. Okay? And since these are happening at 2 different times, we want to add them together because they represent different options. And we see that that's 3,465. Question number 5. Shirley is making a quilt. She needs 3 pieces with a yellow undertone, 2 with a blue undertone, and 4 with a white undertone. If she has 6 squares with yellow, 5 with blue, and 8 with white to choose from, in how many ways can she choose squares for the kilt? There are a lot of numbers here. I like to make sure that I highlight all the numbers to make sure that I'm keeping track. So I've got 3 yellow, and then my next piece of information with with yellow is 6. And then she has 2 with blue, and then 5, and then 4 with white, and then 8 with white. Okay, so we've got yellow, blue, and white. So for the yellow, she has 6 to choose from, and she's picking 3. For the blue, she's got 5 blue, and she's picking 2. And for the white, she's got 8, and she's picking 4. Since these all are going to be attached to one kilt, we're going to make sure to multiply all of these options. And our answer is 14,000.